In this differential calculus lecture video, we will solve the sample problems in the lecture notes I have given you under the topic parametric equations. Now, here is the instruction. Find the first and second derivative of y with respect to x from the parametric equations given. So here, for number 1, we have x is equal to t raised to 3 plus 2t minus 4, and y is equal to t raised to 3 minus t plus 2. So here the target is to find the dy over dx. So it says there, derivative of y with respect to x. So we're looking for the dy over dx and the second derivative of it. Now, here you can observe we have three variables. We have x, y, and t. But we are only looking for dy over dx. So we will remove the parameter t. So we will be removing that by doing some steps which I will show you in this video. So let's solve for number 1. The first solution is to find the derivative of x with respect to t. So given this first equation here, we will find the dx over dt. So that first. So we will have here 3t squared plus 2 minus 0. So dx over dt is equal to 3t squared plus 2. Well, let's just direct it as 3t squared plus 2. The next one is to derive the second equation y with respect to t. So that becomes dy over dt is equal to 3t squared minus 1 plus 0. So the answer here is 3t squared minus 1. So that is for dy over dt. Now what we're looking for is dy over dx. So how will we get that value? Now observe that we have taken dx over dt and dy over dt. What we will do is to divide it with dy over dt over dx over dt. In so doing, okay, so we will have here, of course, since we are dividing fractions, so the denominator is reciprocate. Okay, so dt dx. So if you observe, we are cancelling dt here. So what's left is dy over dx. So, having that pattern, we will also divide here dy over dt divided by dx over dt. The value of dy over dt is equal to 3t squared minus 1 all over the value for dx over dt, which is 3t squared plus 2. And that is now the derivative. So that is your dy over dx. So this is now the answer. Now how about for the second derivative? Now observe that this is our first derivative. Now we will proceed to the second derivative. Now how would we divide that, or how would we get the derivative, the second derivative, if the parameter t is still there? Well, we will derive dy over dx with respect to dt. But we are only looking for dy over dx, right? So that's why we will multiply this with dt over dx, so that we will cancel out dt, and what's left will be d squared y over dx squared, because that is the second derivative. So what will happen here is d squared y all over dx squared. Okay, so how will we do this? We will be deriving this in terms of t. So using the derivative of the quotient, for the derivative of the quotient, we will call the dx uv is equal to v du minus u dv over v squared. So we will also do that here. So we have there the lower part 3t squared plus 2. Then the derivative of the numerator. So we have there 6t minus 0, of course. Then minus, we copy the upper part of the numerator, 3t squared minus 1. Then the derivative of the denominator, which is 6t plus 0. That is over the square of the lower part, 3t squared plus 2. Okay, so that is the derivative with respect to t. Now, if you observe, what we did here a while ago is we multiplied the derivative for this with dt over dx. Now, we will multiply also this with dt over dx. So what we did on the left side of the equation is what we will also do on the right side of the equation. We multiplied it with dt over dx. So we will also multiply this right side with dt over dx. Okay? So now we have d squared y over dx squared, which is also similar with y double prime, right? So this is 6t, this is 18t squared plus 12t minus, this becomes 18t cubed. So this is cube. So may I repeat that process here? So this should be 3. Yeah. 60 cubed. Okay. Plus, this becomes 12t. And then minus 18t cubed. And then minus 6t all over 3t squared plus 2 squared. Then we multiplied it with dt over dx. Where will we find dt over dx? It's this one here, but only the reciprocal. So we have the value for dt over dx as 1 over 3t squared plus 2. Okay, so we continue here. This equal to 18t raised to 3 plus 12t minus 18t raised to 3 plus 6t all over, since we have this multiplied with this one, we will have the value 3t squared plus 2 raised to 3. Therefore, so we cancel this. So what's left here for d squared y over dx squared is equal to 18t all over 3t squared plus 2 raised to 3. So this is now the second derivative. So that is our pattern. So that's for our example number 1. Okay, now let's proceed to the example number 2. We have the equation x is equal to 1 plus t squared and y is equal to 4t minus 3. So let's follow the pattern set in the previous example. First, we will derive dx with respect to t, so dx over dt. This becomes 0 plus 2t, therefore dx over dt is equal to 2t. Next, we have dy over dt. So we are deriving y with respect to t. So this is now 4 minus 0. So dy over dt is 4. Therefore, for the first derivative, we have dy over dt and all over dx over dt. So the value for dy dt here is 4. And the value for dx over dt here is 2t. Finally, we can cancel out dt here. What's left is dy over dx. So this becomes 2 over t. This is our first derivative. Next, let's solve for the second derivative. For the second derivative, we will be deriving dy over dx with respect to t, but we will multiply this with dt over dx. So that is equal to, first we will derive this first derivative, so that becomes t derivative of 2 minus 2 derivative of t divided by t squared multiplied by dt over dx. So that if we cancel this one out, what's left will be d squared y over dx squared. So cancel that one, that is 0. So this is negative 2 over t squared multiplied with the reciprocal of dx over dt. The value for dx over dt is 2t. So dt over dx here will be 1 over 2t. Okay. Therefore, we have here the value for d squared y over dx squared is now equal to negative, okay, we will cancel out 2 there, so negative y 1 over t raised to 3. That is the second derivative. So sample number 2. Next, for number 3, there, go. For number 3, we have x is equal to t raised to 3 plus 7. Then y is equal to 6t squared minus 1. Again, let's do the pattern. So we have there derivative of x with respect to t. We have 3t squared plus 0. That is equal to 3t squared. Derivative of y with respect to t. We have there 12t minus 0. That is equal to 12t. Now, getting the first derivative, we have dy dt all over dx dt. So that we will cancel out dt there. So the value for dy dt is 12t. The value for dx dt is 3t squared. So we will cancel out t and then reduce this. So dy over dx now is equal to 4 over t. So that is the first derivative. For the second derivative, we have there derivative of dy over dx all over dt with respect to t, of course. We multiply this with dt over dx. That is equal to, derive the first derivative again. So we have t derivative of 4 minus 4 derivative of t all over t squared multiplied with dt over dx. So we cancel dt here. What's left? D squared y dx squared that is equal to negative 4t squared multiplied with dt over dx. So what is the reciprocal? So we have there dx over dt equals 3t squared. So this becomes 1 over 3t squared. Therefore, we now have now d squared y, or the second derivative, is equal to negative 4 all over 3t raised to 4. So that is for example number 3. Next, we have example number 4. For x, we have there 3 times t minus 2 squared. Then for y, we have 9t squared plus 4. Solving for derivative of x over dt, we have 3. So we have there, bring down 2 times 3, we have 6t minus 2. 2 minus 1, derivative of what is inside, so derivative of t is 1 minus 0. So have this 6t minus 2. So observe that we are deriving in terms of t. That's why when we derive t, so that is dt over dt, it becomes 1. So 6 times t minus 2. Now for dy, deriving it in terms or with respect to t, we have there 18t plus 0. So dy over dt is 18t. To get the first derivative dy over dx, let's divide dy dt with dx over dt. That is the value for dy dt divided by the value of dx over dt. So cancel dt there. We have dy dx left. So cancel out. So reduce this one. So what's left is 3t over t minus 2. This is the first derivative. For the second derivative, we will be deriving dy over dx with respect to t, but we will multiply this with dt over dx so as to remove the dt. Okay, so let's first derive this. So we have there t minus 2, derivative of 3t minus 3t, derivative of t minus 2 all over t minus 2 squared, then multiply this with dt over dx. Cancel out dt. What's left will be d squared y over dx squared. So that is equal to, so distribute this. That is 3t minus 6 minus 3t all over t minus 2 squared multiplied with the value for dt over dx is 6 times t minus 2. So let's reciprocate that one. We have there 1 over 6 t minus 2. Therefore, we can now cancel out this 3t here. So what's left is negative 6 all over 6 times t minus 2 raised to 3. Cancel out 6. Therefore, d2y over over dx squared is now equal to negative 1 all over t minus 2 raised to 3. That is now the second derivative. Okay, that is for example number 4. Now for the last example, we have example number 5. Given x is equal to 1 over t squared and y is equal to t squared minus 4t plus 1. Let's find the first and second derivative. First, we derive dx in terms of t, or with respect to t. So we have there t squared derivative of 1 minus 1 derivative of t squared over t squared squared. Okay, so this becomes, cancel that one out. So this becomes negative 2t all over t raised to 4. We can reduce that still. So dx over dt becomes negative 2 over t raised to 3. For dy, with respect with respect to t, derivative of y with respect to t, we have 2t minus 4 plus 0. That is equal to 2t minus 4, or we can have it 2 times t minus 2. So that is for dy over dt. Now for the first derivative, we now divide dy dt over dx over dt. The value for dy dt is 2 times t minus 2. The value for dx over dt is negative 2 over t raised to 3. And that is equal to 2 times t minus 2 all over 1 multiplied with the reciprocal. We have there t raised to 3 all over negative 2. So we cancel dt here. So what's left will be dy over dx. Cancel out 2. So what's left is negative t raised to 3 t minus 2. That is the first derivative. Next, for the second derivative, we have derivative of dy over dx with respect to t multiplied with dt over dx. So we can cancel out dt. So let's derive first this one. This negative t raised to 3. Derivative of t is 1 minus derivative of 2. Then we have there plus. So we're doing a derivative of a product. So t minus 2. So derivative of product, they are addition. Then derivative of negative t raised to 3, negative 3t squared. Then all of this we will multiply with dt over dx, just to balance the equation. Since we have dt here, dt over dx, we have dt over dx there also. Okay? So cancelling out dt, we have d squared y dx squared, that is equal to negative t raised to 3 minus it's minus 3t squared, no, that is 3t raised to 3. Okay, then we now have here plus 6t squared. Then the dt over dx here is, yeah, you can put it like that. There you go. Our dx over dt is negative 2 over t cubed. So dt over dx will be negative t cubed over 2. Okay. So this is negative 4t raised to 3 plus 6t squared. Then we have here negative t raised to 3 all over 2. So if we observe this carefully, we can now cancel out here. So this becomes 2, this becomes 3. Okay, I hope you get that part there. Okay. So if that is the case, we will just put here negative t raised to 3, or we can just show it first so that let's just distribute. So negative, positive 4 t raised to 6 all over 2, okay, minus 6 t raised to 5 all over 2. So we cancel out that. That becomes 2t raised to 6 minus 3t raised to 5. So t raised to 5 times 2t minus 3. That is the second derivative. So that is for number 5. Okay, so that's all for parametric equations.